Alright, yesterday our quadrilateral, our special quadrilateral was this. And it was a rectangle, right? Which means it's a quadrilateral with what? Four right angles, okay? That's all you got to say. If you have a four-sided figure, quadrilateral, and all four angles are right angles, then it's going to be a rectangle. If it's a rectangle, that means it's also a what? Just because it's a rectangle doesn't mean it's a square. We haven't even mentioned square yet. Well, it's a parallelogram, right? It's a parallelogram. So if it's a parallelogram, you know a bunch of stuff. You know the opposite sides are equal to each other. You know the opposite sides are parallel to each other. Okay, you know the diagonals bisect each other. You know the opposite angles are equal to each other. You know the consecutive interior angles are supplementary, right? You know a bunch of stuff just by knowing that a four-sided figure's got four right angles, all right? So that was just review from what we did yesterday. Today we're going to do a special type of quadrilateral. In fact, we're going to do a special type of... I tell you what, let's do this before I was getting a little ahead of myself. Let's do this. Okay. Now we're not done yet. I'm going to change it a little bit. And I don't know, let's go 20 degrees, see what that looks like. That looks pretty good. Now I think by doing that, I'm not sure what that did to it, if it made all the sides equal to each other or not. Tell you what. Just bear with me a second. I just want to see something. I want to see. I think, okay, so that's that length. Because I think this side looks a little longer, don't you? Let's just see. Yeah, it is. So let's drop this one just a little bit, about right there. That's a little closer, I guess. I don't know. We'll see. That still looks a little longer, doesn't it? I'm looking to see if all these sides are equal to each other. Does that look like all the sides are equal? Still go a little bit more? Like that? Does that look a little bit better?
Yeah.
Okay, so that, let's just, sorry about this. Oops. Just bear with me. Okay, so what I'm going to do is I'm going to just take this, put it here, flip it around, and see if it's... Oh, it's a little bit too long. So I gotta move this up just a little bit. So that should be about right, shouldn't it?
Yeah.
Alright, let's put that there again. Let's see. Okay, that's that length, and that's close enough. Close enough for government work, as they say. So I used to work for Del Dot, and anyway, that was government. That's what they used to say. Alright. What am I going to do with this? Okay. What did I just take a lot of extra time to do? In fact, you know what I'm going to do too. Let's do this for the next class. Let's just copy and paste it, and we'll put it over here off to the side so I don't have to go through that again in my next class. And then I got it already built for me. Okay, cool. So here we go. We've got a quadrilateral, and I tried anyway to make all four sides equal to each other. Okay, so if you take a look at this, if all four sides are equal to each other and it's a quadrilateral, look, these two opposite sides are equal, these two opposite sides are equal. So what is this thing now? If I have a quadrilateral with both pairs of opposite sides equal, now it's a what? It's a parallelogram, isn't it? But it's a parallelogram that's a little bit special because all four sides are exactly equal to each other. It's not like these two are equal and then these two are something different and they're equal to each other. All four are exactly the same. And we have a special name for that, and we call that a rhombus. Notice the spelling. R-H-O-M-B-U-S. Okay? That's a rhombus. So a rhombus is what? It's a quadrilateral with four equal sides. I want to see what they do. Now they say in the book it's a parallelogram with four equal sides, but I don't think you have to say it's a parallelogram. I think you can just say it's a quadrilateral with four equal sides, because if you draw a quadrilateral, any four-sided figure, and all four sides are exactly the same, okay, that means that the two opposite sides, these two opposite sides are the same, these two opposite sides are the same, so that automatically makes it into a parallelogram, doesn't it? All right, so I think we can get a little bit more basic and say it's a quadrilateral with four equal sides, even though the book says it's a parallelogram, which is true. It is a parallelogram with four equal sides, but anyway, there you go. So that's what a rhombus is. A rhombus has four equal sides. Now, does a rhombus always have to be slanted exactly like that? Now, you could slant it a little differently and still have four equal sides. In fact, you could do this. This won't be too hard. You could do that. Is that a four-sided figure? Is that a quadrilateral? Yeah. And I purposely made that so all four sides are equal. So this thing right here is also a what? It's a rhombus, isn't it? Now, somebody said square, but can you say that's a square with that given information right there? You can? Who said yes? Why can you say that's a square? Are you kidding me? After all the weeks and weeks and weeks we've talked about just looking at something and say it looks like it, you're still going to say because it's shaped like it and it looks like it? Come on. We can't do that. We got to go by the facts, don't we? It's not a square because what would a square have to be? And you know this from being a little kid. You learned about squares. You got to have right angles in here. Exactly. Okay? You don't know that's a right angle. Now, it looks like it, doesn't it? All right? But you don't know for a fact that that's a right angle. So you can't say just with this information right there that that's a square. You have to know that you have right angles. So you did your calculation. Sure you did. So if I put these right angles in here, now you could say it's a square. So let's take a look at a square. A square is a quadrilateral with four right angles. That means a square is also a what? Now listen to what I just said. Listen to what I just said. Well, yeah, they're all parallelograms. Thank you. It's a quadrilateral with four right angles. What did we define a quadrilateral with four right angles to be? A rectangle. A rectangle. Okay, we defined, I didn't say anything about the sides being equal. I said a quadrilateral. Watch. Here's a quadrilateral. Okay, and I've got all four right angles. What is a quadrilateral with four right angles? It's a what? It's a rectangle. Thank you. Okay, for about the fifth time, I think we might get it. Okay, this is a rectangle. So, forget that I have these sides equal to each other. Maybe that's throwing you off, okay? But the question that I asked you is, you've got a quadrilateral with four right angles. What is this thing right here? Just with that information, what can you say that is? A rectangle. You can't say it's a square yet. Okay, you can only say it's a square when you have four right angles and what else? Four equal sides. Okay? What if I just had the four equal sides and not the four right angles? What could we call it? A rhombus. Okay, so if it's got four equal sides, it's a rhombus. If it has four equal angles or four right angles, then it's a rectangle. You put the two together, you get a quadrilateral with four equal sides and four right angles, then you can call it a what? A square. Now we can call it a square. So basically, a square is a rhombus, isn't it? Because a square has four equal sides, and so does a rhombus. Agreed? So a square is a rhombus, and a square is also a what? A rectangle. So square is both of those. And all of them, a rhombus, a square, a rectangle, are all part of what big family, what big umbrella?
Shapes.
Well, that's a pretty big umbrella. Yeah, they are shapes. Okay, it's a quadrilateral. So let's do this. Let's kind of do a little hierarchy here. The most general type is a quadrilateral, right? And then we got a little more specific. We said the opposite sides are equal, the opposite angles are equal. What do we call that thing? A parallelogram, okay? Goodness gracious. I'll count it out. I'll count it due to being early in the morning. It's okay. So watch. You have a quadrilateral, and then more specifically is a parallelogram. And then under parallelogram, you have you got rectangles. Okay. And then under a rectangle, you have a. Okay. Well, no. You would say a square. Watch, if you come over here to parallelogram, you have a special type of parallelogram, which would be a what? A rhombus. It's not a rhombus, it's a rhombus, okay? Okay. And then watch. Square could actually, you could have arrows going to both of those, couldn't you? So look at this. Every parallelogram is a quadrilateral. Would you agree? And if you want, Ricky, we'll put shapes, okay? So these are all shapes, all right? That's just kind of silly. But anyway, we got quadrilaterals. Under that, you have special type of quadrilaterals, which are parallelograms. And then under that, you have two types of parallelograms. You've got a rectangle and you have a rhombus. Okay? Under rectangle, you have a special type of a rectangle, which is a square. Okay? I guess if you want to think of it that way. But this is a, listen to me. Then another special type of parallelogram is a rhombus, which means 4 equal sides. A square is all of those. So what's a square? A square is a rectangle, it's a rhombus, it's a parallelogram, it's a quadrilateral. Do you agree? Okay, and it's a shape, of course. All right, does that make any sense? All right, let's go through some special things about these, about a rhombus and a square. Now, if you look at the title of the lesson, anybody have that out? Yeah, they. Oops, what did I was gonna say? Right, rhombi. What do you think? What's up with that? What's rhombi? Yeah, it's plural of rhombus. Well, it's not plural of rhombuses because that's not a word. It's the plural of rhombus. Okay, so rhombi means 2 or more. Rhombus. Okay, does that make sense? And of course, the plural for square is just squares. It's not that big of a deal. All right, let's talk about a rhombus and a square just a second. Let me see what the first one is that they do. Okay, let's grab that rhombus that we drew earlier. It's right there. Now, we haven't talked about, what's one thing that we've done with parallelograms? We talked about opposite sides, we talked about opposite angles and all that good stuff. So if this is a rhombus, and I'll tell you right now that this is a rhombus, what do we know about this if it's a rhombus? Well, we know all the 4 sides are equal to each other. What else? It's not a square also. Okay, this is just a regular rhombus. Okay, I don't know that these are right angles right here. But just because I know it's a rhombus, what do I know about it? I know that all 4 sides are equal because it's a rhombus. Now, if it's a rhombus, it's also a parallelogram, which must mean what? That the opposite angles are equal to each other. It means the consecutive interior angles are also what? Supplementary to each other. So whatever this angle is and this angle, they add up to 180. This one and this one add up to 180 and so forth. Everybody with me so far? Okay. What's another thing that we've been doing with diagonals? Right, so let's talk about the diagonals. Now, because it's a parallelogram, what do we know about the diagonals? They bisect each other, right. Just for the fact that it's a parallelogram means that the diagonals bisect each other. Okay? Everybody understand that? But so that's not really special. There's really nothing special about this that we haven't known already, except for the fact that all 4 sides are equal to each other. And we knew that by the definition of rhombus. But let's take a look at the diagonals. What does it look like? Just kind of eyeball it. Look at this diagonal. Does it look like they're equal to each other? No, because the diagonals are only equal to each other when it's a what? A rectangle. We learned that yesterday. Okay, the diagonals of a rectangle are equal to each other. This is not a rectangle, so these diagonals are not going to be equal to each other. Now, we do know they bisect each other. All right, so that means that this and this are equal, and this one are equal. It does not mean they're all 4 equal to each other like it was in a rectangle. But there is something else that this does, and I want you to look at this. Look at this angle that they form right here. What does it kind of look like it might be?
Right angle.
It looks like it's a right angle, and it absolutely is. Okay, and it's not a right angle just because it looks like it. All right, there is a proof for it. We probably won't go through the proof, but if you want to look in the book, I'm sure that they do the proof somewhere for this. But that right there is going to be a right angle. So what do the diagonals do? I'll tell you what, let's do this before we... okay, they bisect each other because it's a parallelogram, but specifically because it's a rhombus. Let's write down 2 things that are true about a rhombus. All 4 sides, all the sides are what? Equal or congruent. Okay, so that's one thing we know about a rhombus. What's another thing we know? We know that the diagonals Well, they bisect each other because it's a parallelogram, but that's not really specific to a rhombus. Okay, they do bisect each other, that's true, but that's not specific to the rhombus. What's specific to the rhombus about the perpendicular, I just gave it away, about the diagonals? They're what? They're perpendicular, right. They form a right angle right there, so the diagonals are perpendicular. That's specific about a rhombus. That's not true about any rectangle. That's not true about any parallelogram. It's only true about a what? About a rhombus, okay? So these are specifics that are only true about a rhombus. They're not true about all the other things that we've talked about. Does that make sense? Okay? So those are the specialties of a rhombus. What were the specialties of a rectangle? Well, all four right angles, and the diagonals do what? Well, they bisect each other because it's a parallelogram. They're what? They're equal to each other on a rectangle. Okay, what's true about the diagonals of a rhombus specifically? They're perpendicular to each other. Okay, so they form a right angle, which means you got right triangles in here, don't you? Look, if that's a right angle, then guess what? All four of these inside of here are right angles. Everybody see that? So I've got four right triangles. So you could think about some of the questions they're going to ask you. They might give you a couple sides, and you might have to find the third side. How would you do that? If you have a right triangle and they give you two sides, are we listening, paying attention up here? If I have a right triangle and they give you two sides of a right triangle, how do I find the third side? We've done that this year. Pythagorean theorem, that's right. So think about that. When you think right triangles, think Pythagorean theorem. Because, now I don't know specifically, I mean, I didn't look at every single problem here, but my guess would be that you may have to use Pythagorean theorem. If they give you a couple sides, you might have to use it to find that third side. Does that make sense? Okay, so, think about that. All right, we've got another one to do. Let's do, so that was specific about a rhombus. Now what are we going to do? What was the other thing we talked about earlier? Come on, you're killing me.
Square.
What was the other thing? A square. Thank you.
Wait, we don't know it's a square yet.
Okay, I know, but I said what was the other thing that we talked about today? We talked about a rhombus and we talked about a what?
Square.
A square. So let's make this into a square. So square, you got to have two things that are true. Just because it has four right angles doesn't make it a square, does it? It does make it a what, though? A rectangle. It makes it a rectangle, okay? The four right angles has nothing to do with it being a rhombus, okay? The four right angles makes it a rectangle. So this right now is a rectangle. What if I did this? Okay, right. That makes it a rhombus, which makes it, if you have a rhombus and a rectangle combination, right, what do you get? You get a square. All right, so that right there is a square. So what do we know? We know the opposite sides are equal. We already see that. We know the opposite angles are equal. That's easy to see. We know the consecutive interior angles are supplementary, right? 90 and 90. Okay, what's the other thing we need to look at? The diagonals. So let's look at this. Well, yeah, they bisect each other because the square is a parallelogram. So that's not special about a square. The diagonals bisect each other on any parallelogram, right? That's not special about a square. Now, what do you think? Just look at it. We're just eyeballing here. Now, first of all, this is also a rhombus, isn't it? A square is a rhombus. Why is a square a rhombus? Because a square has four equal sides. So you know that that's a right angle right there, don't you? Okay? You know the diagonals bisect each other. That's true. It's a rectangle, so you also know that the diagonals are what? Are equal to each other. That's right. So from here to here and from here to here are equal. That means that this, and this are all equal to each other. Right? Man, there's a ton of stuff that we know now. We're kind of putting all of those things together into this one. Square is kind of like a combination of all the stuff that we've studied so far. Right? What's another thing? We know the diagonals are equal to each other. Here's another thing that's true. Look at this. Look at this angle. I know it's a right angle. Okay? Let me just shoot. There was another thing about a rhombus I forgot to mention, and I had it in my mind, and I completely left it. But we'll do it with this one. Look at this diagonal right here, and this also works for a rhombus. Look at this angle and look at this angle. Just kind of eyeball it. What do you think might be true about these two angles right here? They are. They're exactly the same. Okay. And I should have told you this about a rhombus, and I completely forgot. All right. So let's, in your notes, you know I had 1, 2 for the rhombus. Let's add a number 3 to the rhombus, which says that the diagonals, they're not just perpendicular, But what do you think they do? They bisect the opposite angles. That's right. Okay, the diagonals bisect. I completely forgot to put that on there. Bisect the opposite angles. Okay, which means if you have a rhombus, and a square is a rhombus, isn't it? All right, so that means it bisects. Now, since this is a square, though, look, that's a right angle. If I bisect a right angle, how many degrees is that angle right there? It's 45 degrees, exactly right. So the diagonals of a square form a 45-degree angle. All right, so if I have a square and I draw a diagonal from one corner to the other, I formed a 45-degree angle. Everybody with me? All right. So sorry about that on the rhombus part, but just add that in your notes, okay? So what are the three things about a rhombus? All four equal sides, the diagonals are perpendicular, and the third thing, the diagonals bisect the opposite angles. We got it? So man, there's a lot of stuff you know about this. You know that's 45. Look, all those angles right in here. Do you see this one, this one, this one, this one, this one, this one? They're all 45 degrees, aren't they? You know the diagonals are equal to each other. You know the diagonals bisect each other, which means all four of these segments are equal to each other. You know they're perpendicular, which means that's a right angle right there. You know all four of these sides are equal because it's a rhombus. Man, there's a ton of stuff here that you know about a square. I bet you when you were a little kid and you first learned about shapes and circles and squares and rectangles, you probably had no clue. You could learn all that stuff just about a simple little square. All right, but it's a lot more complicated than what you thought. All right. Let me see one more thing. I think there might be something else. Let's see, there's a rhombus and perpendicular. I think we've pretty much covered everything. Let's do a quick example here. All right, there we go. I forgot to record this, but only one or two of you watch this thing anyway. I looked last night. Anybody try to look at yesterday's lesson? No. Okay. Yeah. Let's see. Is there anything else we can find here? That's about it as far as the angles, right? Yeah, because we found all the angles and that's all they told you. Pretty easy stuff. What if they did this? Here's another one. They say GH is equal to x plus 9 and JH is equal to 5x minus 2. Find x. All right, so let's see what we can do here. GH is this one right here, and that's x plus 9. What's that? Right. If you don't put a line segment over it, it means the length of the segment. Right? So GH is if there's no thing over top of it, it means the length of, or the measure of that length right there. So that's x plus 9, and then JH is this bottom one, which is 5x minus 2. And it says solve for x. So how in the world are we going to solve for x here? Okay, how do you know they're equal to each other? Because it's rhombus. That's right, because I told you right at the beginning that this thing was a rhombus. I should have written it down. So this is a rhombus. So you just set them equal to each other. Couldn't be easier than that. All right, so 5x minus 2 equals x plus 9. Subtract that. That's 4x. That's 11. So it's 11 over 4. If you work it out, it's 2.75. You could keep it 11 over 4. In fact, if I was going to do that problem, I would probably just keep it like that. Wouldn't you? Okay. Is there anything else we can find? I think that's pretty much it. All right, they told you the sides. Let's see. Yeah, they didn't tell you diagonals, so there's really not any way that you could figure out that. Later on, at the end of the year, we're going to be able to figure out what the lengths of these things are because we're going to do some trig. Do you ever do any trig? Sine, cosine, tangent? Did you guys ever learn any of that stuff? Okay, so we're going to be able to find the lengths of these things by using sine, cosine, and tangent because we've got a right angle. We haven't done that stuff yet. We haven't done that stuff yet, so that's in the future. All right, that's pretty much it. Let's give you an assignment to do. I know you don't want to miss out on that. So it's pages 431, 432, 7 to 12, and 23 to 30. And it's section 6.5. Everybody got that down? Yeah.